This tool is a demo tool in general. This is the finished tool face. We start off and we lay approximately 5 plies down, and then it goes through a curing process. It's a BMI material, so it's good for 350 degree cures, and we've tested it up through 800 cycles. The material comes out in a roll that's roughly 18 inches wide and about 40 feet long. These pieces are cut into panels and then put onto a master tool to make the tool itself. This tool could be made to be 30, 40 feet long in the same geometry, and it's again, you save on your capital costs in that it's much lighter and easier to move around your factory floor. If this were a piece of Invar, I wouldn't be picking it up and moving it around like this. You know, one of the things that is very good about this is that it is machinable. You don't have to put a ton of work or expense into coming up with a master, because you're going to take the initial plies off and machine that surface, so you put your detail of the geometry into the final surface. Also, we can compensate for spring back. We can add more material on it. We can take material off of it to get to the final geometry of the parts.
Christie Cap is essentially a product that we developed a few years ago. We took our legacy and knowledge of building honeycomb structures, and we inserted a mesh material inside the honeycomb cell, and we found out that it has acoustic dampening properties that were very useful in applications like nacelles of engines, where noise and acoustics are really important. So when you look at the product, it has the ability to form well in an application like the engine nacelle, and it helps really engine manufacturers and airplane manufacturers to be able to offer a product that meets a lot of the noise and noise emissions requirements that are right now very important in the marketplace. So you look at airports where cities are getting built around, noise requirements are increasing, penalties and fines as certain airplanes exceed noise limits are really important right now. So what we have with this product is the ability to be able to shield that noise, very good performance, high performance, noise dampening, and it basically helps them achieve that. We currently manufacture it in fiberglass core. We have the piece that's here is made out of aluminum core. It's offered today. It's installed on airplanes that are currently out today.
The A350 program is a very, very key program for Hexcel. We're developed a primary structure material where we have had it qualified at Airbus. We have got numerous manufacturing facilities qualified throughout the world. Just recently we're qualifying our new Salt Lake City plant, where we've introduced very state-of-the-art next generation manufacturing technology processings that we have get in the process of qualification, and we hope to be in production in the first part of 2014. Both of the stringers and the frames are made out of our IMA fiber, which is produced in Salt Lake City, and our M21 resin chemistry that we have qualified through Airbus. It's a 350 toughened epoxy that delivers extremely good performance for structural applications. What we have done is we've done a very good job at modeling very large volume manufacturing processing with the premium qualities of our IM fiber with a toughened epoxy resin system. What is unique to this program for Hexcel is that we have developed a manufacturing concept that includes very large volume resin and filming capability with local satellite manufacturing on the pre-pregging side. So we bring the pre-preg manufacturing close to where our major customers are. In Europe, there are several satellite facilities already established and qualified. In the U.S., our Salt Lake City plant will be there to support our domestic customers. Our high-type product is a very new material technology that it utilizes our own carbon fiber, some unique veil chemistries that we apply to the fiber, and a new infusion. Well, it's a traditional RTM infusion resin that we have that's been characterized to deliver, basically the same performance as a toughened epoxy pre-preg. And on this particular part, we asked one of our major customers to help us fabricate a demonstrator part that utilized the high tape material. We used our technical service representative to help fabricate the part with them. And it was a great collaborative effort where we were looking at it from the standpoint of trying to build a very large structure, one that they could take a look at, and from the standpoint of doing some production cost estimates to see if this technology was a cost-effective technology. And it also helped us prove out the material concepts. And so it's really good combination of Hexcel material technologies that's going to build a fundamental change in how our customers build parts. The preforms, what's nice about it is they come in traditional packages that our customers are familiar with. The packaging is something that's common with traditional prepregs today. What's uncommon is that it doesn't have barriers or interleaf materials. It doesn't have to be stored at cooler temperatures during the application process. So there's the ability for our customers to use these on automated fiber placement machines is much, much more easier, and they can get higher uptime on the equipment, which leads to more productivity.